CCI, Crash Course Instrumentation, presents episode number 74, Mixed Sources and Amp, Practical Banks, Finale. Standing credit. Thank you to Tony R. Coupalt and the open source community for the Model project, CC by 4.0. Hook. Can a device be a source in one moment and a load in the next? Yes. And understanding that flip is the key to real series parallel systems like battery banks and resistor networks. Roadmap. First, a plain English way to tell source versus load using current direction and polarity. Next, how to solve a small mixed source circuit in words only. Then, practical rules for building banks of identical parts, resistors, batteries, and solar modules. Finish with 2 quick checks and a recap. Terms in plain English, one time. KVL, Kirchhoff's voltage law. The sum of rises and drops around any loop is 0. KCL, Kirchhoff's current law. Currents into a node equal currents out. Source versus load test. If current enters the Kafka negative side and leaves the Watt positive side of a device, the device is giving energy. It behaves like a source. If current enters the Y positive side and leaves the one on negative inside, it is absorbing energy. It behaves like a load. Bank. Multiple identical parts arranged in series, in parallel, or in a series parallel pattern to achieve a target voltage and current. How to spot source versus load without math. Say out loud what the current is doing relative to the device's plus and home marks. Into plus out of minus, it uses energy, load. Into minus out of plus, it delivers energy, source. The same physical part can switch roles depending on the rest of the circuit. Mixed source circuit in words, no drawings. Imagine a loop with a voltage source on the left and on the right side, a current source feeding downward into a parallel pair of equal resistors that rejoin the loop. One more resistor sits in series on the bottom. 1. Mark what's given. The voltage of the voltage source. The current of the current source. 2. Reduce where you can. The 2 equal resistors in parallel act like a single resistor that is half one of them. 3. Apply the given. The current source tells you the branch current it pushes. That immediately sets the voltage across the parallel block. Ohm's law in words. Voltage equals current times resistance. 4. Expand to the series path. The same loop current must pass through the bottom series resistor. Now you know its voltage drop from current times resistance. 5. KVL check. The voltage source rise must equal the current source branch's drop plus the bottom resistor's drop. If it balances, the numbers are consistent. If not, retrace signs and shared quantities. Practical banks, identical parts, predictable results. Resistor banks. Series adds resistance, parallel reduces it. Use series to limit current and parallel to share current across parts. If you need a non-standard value, combine identical resistors in series parallel to hit the target while spreading heat. Battery banks, identical cells modules. Series raises voltage, parallel raises available current, or amp hours. So keep cells matched in type, age, and state of charge. Mismatched cells force balancing currents and reduce life. And include proper fusing or individual protection for each parallel string so one failed cell does not dump into another. Polarity discipline, one reversed cell becomes a load and can overheat, trace +2 carefully before energizing. As solar module banks, identical modules. Series strings raise voltage to meet inverter or charge controller requirements. Parallel strings raise current for power. And shading turns a sunny module into a load, unless bypass diodes help, designed so partial shade cannot collapse the whole string. Rules of thumb you can say out loud. Series raises the number you add, resistance or voltage. Parallel shares the push and lowers resistance, but raises available current. Protect each string so one fault does not drag the rest down. Decide the bank by the target at the terminals. Need more voltage? Add series. Need more current? Add parallel. 2 quick checks for any finale design. Loop, KVL. Voltage source rises equal all drops in a complete loop. Node, KCL. Sum of currents into any junction equals sum out, especially where strings join. Power sanity. Source power equals total load power. If a device shows negative power, it is acting as a source by our test above. Recap and close. Mixed source thinking is simple if you label signs and say the roll test out loud. For Banks, series for voltage, parallel for current, protect each path, and keep parts matched. With KVL, KCL, and a quick power check, you can trust your series parallel designs. Thanks to Tony R. Coupalt and the open source community. If this series helped, like and subscribe to Crash Course Instrumentation, and share it with a classmate who's wrestling with combination circuits.